This is video 3 in chapter 2. We're going to talk about data types, and we're restricting ourselves to the numeric data types, int and float. Int, again, is a data type of whole numbers. Float is a data type of real numbers. Integer data types can be signed or unsigned. There's actually a data type called unsigned, which is just numbers that never are treated as negatives and positives. Integer data types come in different sizes, and the size is in terms of bytes. The smallest integer data type is short, and it typically is 2 bytes long or 16 bits, and it's capable of holding numbers up to 32,000. It's really 16,000. A regular int typically occupies a complete computer word, which is typically 4 bytes or 32 bits, and with an int you can hold values up to approximately 4 billion. A long integer occupies at least 8 bytes or 64 bits, and it can hold numbers much bigger. For integers, there are different operators, and the operators pretty much conform to what we've always learned about numbers. We can add, subtract, multiply, and divide. We will see shortly that there's one additional operator for integers. Now, from math, you know that operators can be unary, that is, they only require one operand, such as negation. If I take the number 4 and apply negation to 4, I end up with -4. So that's negation. Other operators are binary. Binary means you need 2 operands. And normally, if we want to add 2 numbers, numbers 5 and 7, we write it as 5 plus 7. There's actually a name for that way of expressing addition. It's called the infix notation, in the sense that the plus sign is in between the 2 operands. There's one on the left, one on the right. Think about binary division. What does it look like? It looks like one number, the symbol slash for divide, followed by the second number. All right? And think about subtraction. With subtraction, the order in which you put the operands does matter. 3 minus 7 is not the same as 7 minus 3. In C++, there are some rare operators. They're not really arithmetic, that require 3 operands, and we'll talk about this in about a month or so. This funny looking guy here. Now let's take a closer look at the binary arithmetic operators that are defined for whole numbers. Addition is what you think it is, subtraction is what you think it is, and down through division. Let me remind you, when you have division, the number that you're dividing into, the mathematical term for that is called the dividend. The number that you're dividing by is called the divisor. If you recall from elementary school, when you learned to do division the first time, you would say 7 divided by 3 is 2, remainder 1. So basically there are 2 operators related to division. One is division, and the answer that you get from division is the quotient, the 2. The other operation is called modulus, or remainder, and it tells you when you do the division, I don't want the quotient, I want the part that we used to call the remainder. So when I divide 7 by 2, I get a quotient, 7 by 3, I get a quotient of 2. This is the quotient. But with the remainder of 1. So when I do this operator, which we typically call mod, short for modulus, it gives me the remainder. Now this function is a little tricky, so you might want to remember what you see here. What you see is when the dividend is negative, what is always negative? The mod is negative. When the dividend is negative, the mod is negative. When the divisor is negative, it does not have an impact on the sign. So whether or not the mod is negative depends on the sign of the dividend. All right. There's something else alarming about the divide operator for integers. And it's real simple. When we first learned division, we said the answer, the quotient, is just the 2. It is not 2 point anything. But when we do integer division, the result that you get is an integer and nothing but an integer. Later on, you learned that 7 divided by 3, if you wrote it as a decimal number, it would be 2.2 1/3 or 2.3333. But when we're dividing two integers, the quotient is always what data type? An integer. There is no decimal. So be really careful about this. So if that's the case, when I divide 13 by 5, the answer is not 2.6 like you might think. It is 2. When I divide 2 by 4, what's the answer? 4 goes into 2 0 times with the remainder of 2. So the quotient is 0. Now, on the other hand, if you mix whole numbers and decimal numbers, then the rules for dividing switch from the rule for dividing integers to the rule of decimals. So when we encounter this, we treat this 13 as if it was a decimal number or a float number, and we do the division as if everything was float. And the result there is not an integer but a float. Same thing here. The result here is not an integer but a decimal or float. Now the mod operator, again, is the remainder from division, and it is only defined for two integers. This is an integer, this is an integer. I can take the remainder of dividing 9 by 2. If one is an integer, the other is not an integer, then the operation is not defined. You will get an error trying to do that. Now let's talk about floating point numbers. A floating point number, just like integers, will come in different sizes. And the smallest size is a float, and it's typically 32 bits. A double is typically 2 computer words, 8 bytes or 64 bits. And a long double can be as much as a double or 4 words. All right. What do you gain by having a double versus a float? In scientific calculations, you basically get more significant decimal places. With a float, you normally carry about 6 decimal digits. With double, you can carry up to 14. And with long double, you can probably carry 20-some. All right, let's take a look at floating point constants. If there's different notations, and you need to get used to the terminology. One notation is called a fixed point notation, which is the way we normally write decimal numbers. We do our checkbook with fixed point because we have a decimal point and a certain number of places after the decimal point. Okay? The other way that we write, especially if we take a class in physics or in science, then all of a sudden we use scientific notation. We don't write all these digits out. We just write a number and then say give an exponent. So the e is the same as writing times 10 to the power 1. This is like writing times 10 to the power minus 5. Right? So a floating point constant by default is double. The data type is double. That is, it is represented using 64 bits and not 32 bits. The constant is. We can force a float constant to be a smaller float by putting the letter F after it or the letter L, which will make it a larger constant. If I put an F here, it says represent this constant with 32 bits. If I say L here, it says represent this constant as 128 bits. Now this is the last little thing we've got to get across to you, is that a number is a number up to a point. Let's say it a different way. Every integer is also fully a real number. The integer 4 is really the decimal number 4.00000. Conversely, is every real number an integer? No. 4.1 is not an integer. So if I have the value 4.1 and try to store it as an integer, how much of it can I store? Well, you can only store the part that's an integer, and that's the 4. The 0.1 is not an integer, you can't store it. So when you go to store a float value into an integer variable, you got to throw away the part that's not an integer. The part that's not an integer is the decimal part. It's the fraction part. So if I store 3.88 into an integer variable called rainfall, what happens? We truncate. We throw away the fraction part. So we only keep the part to the left of the decimal point. All right? With that, we're going to stop.